Hopefully it's working today. Okay, so what we're gonna do today is we're gonna continue on this question, and I think you guys know how to do it. We talked about the first part already, finding molarity. Now we're gonna do step by step, explaining how to create the solution calculated in the step B. So how we're gonna create full molarity of the solution. Okay, full molarity of the solution. We're gonna go with that number first, the mass, right? We're gonna say measure, right? 212.0 gram of. If you don't want to write the formula, you can write the name. I'm just gonna write the formula: sodium carbonate, CO3. That would be 2. If you're gonna choose to write the formula, make sure you write the correct one. Okay. And also, it's always a good habit to write down what you use to measure. I will probably say using, balance, right? Okay. And of course, you can also say, measure the beakers and then use the beaker difference. But yeah. And then we're going to say add, right? Na2CO3 into, I don't know, you can say 500 milliliter volumetric flask. Okay. And then what we're going to do is, now we're going to add water. And, oh, why I keep writing unit nowadays? Until, right, total volume in the flask is 500 milliliter. Okay, you can say this part, you can just kind of get creative. You can use stopper, stir, shake, right, invert it, whatever you can say. Stopper, stir, I don't know, you can say shake gently, whatever. The end goal you want to say was until all Na2CO3 dissolve, or you can say mix evenly in water. Okay. Or some people would say until the solution is uniform. Okay, because you want a homogeneous mixture. That is what we call solution add. All right, let's try to write down an equation on what happens when you add sodium carbonate into the water. Well, notice that sodium carbonate and the water, that is not reaction. It's simply break it into a part. So if you guys don't want to, you don't necessarily have to write water, because what you're gonna have is just this. Na2CO3, right, is just gonna become Na plus and then CO3 minus 2, and then you're just gonna balance that. That's what is gonna happen. And we know it's a single arrow, single direction, because Na2CO3 is very, very soluble. It's one of them, right? It's an alkaline metal. So alkaline metal are very, very soluble in water. So therefore, it's gonna be through that. Okay, now let's talk about molar concentration. What do I mean when I say molar concentration? I talked about that one before. What is molar concentration? Anyone know what unit are we looking for? Molarity, right? Big M. Molar concentration is molarity, big M. Now we're looking for each ion. So what are we talking about? The ion. We are looking for the Na plus, and we're also looking for CO3 minus 2. Pay attention that when you write CO3, your O and C are the same size, because I have problem with people writing the O tiny o. What happens when you write big C and tiny O? Cobalts. Okay. All right. Now what we're gonna do is we're gonna write the formula. Now I'll talk about molarity. What is the molarity of Na and CO3 is gonna be? Well, let's take a look at up here. We know the molarity of Na2CO3, right? That's a molarity of Na2CO3. So in a one Na2CO3, how many Na do you have there? 2. So therefore, molarity of Na plus is gonna to be 2 times 4.0. That would be 8.0 molarity. CO3, right? Notice again CO3, the same thing. So that's just gonna be 4. Okay, there you go. Something like that will do. All right, how many gram of sodium carbonate are present in the 40 milliliter of this solution? So what do you think they are asking now? Well, I mean, obviously they said grams, so you're gonna find grams. But what are they saying? They said 40 milliliter of this solution. So what are they saying? What is the process? Well, the question said when you're creating the solution, right? This solution is 4 molarity or 4 molar concentration, and total volume is 500 milliliter, right? So you have a solution, 4 molarity, 500 milliliter. What I'm asking you guys to do was I said you dump 40 milliliter. Now you got a smaller beaker, right? 40 milliliter solution. So what happened with the 40 milliliter solution? How much substance is gonna be there? That's what we're trying to figure out, right? So you're saying I have a little beaker and I have a big beaker. I'm pouring it in. The solution that I'm putting is 4 molarity, right? Sorry, 4 molarity solution, right? It has 500 milliliter that in there. So I'm pouring only so that I have enough to have 40 milliliter. So now my question to you is this: in this 40 milliliter, how much of Na2CO3 is in there? How much Na2CO3 is in there? Okay, so what we're gonna use to find grams? Okay, let's think about that for a second. Grams, I want grams. Gram is connected to usually what other unit? Molarity, probably mole, right? So grams is gonna connect to moles. Moles in this case connect to molarity. So guess what? We do have a molarity here. We said the solution was 4 molarity, right? By pouring a little bit into this beaker, did my molarity or my concentration of the solution change? No, because you're just literally pouring out, right? So, I mean, assuming that, nothing settled and it's still equally mixed, this here is still 4 molarity, agree? So, if you know the molarity and you know the liter, what can I find to find grams? The mole. Molarity, liter, moles to grams, agree? Okay, see, this is what I mean by thinking. You guys see that? I just work out thinking problem out with you guys. Literally, you can do this question on your own if you wanted to. We talked to you guys this before, right? We talked about this one before. We worked on it. But now I just kind of put it in a question. So now let's put that together. So we know 4 molarity. Now, I like to write my molarity. Right? The molarity always as mole over liter because it's make it a little bit easier. Okay, I don't want a liter, so that means I'm gonna multiply with liter. Well, 40 milliliter is how many liter? 0.04 liter. Okay, so we know that one. 0.04 liter. That will get out my liter. Okay, I have my mole. I don't want mole, so how do you do that? Convert to grams using molar mass, right? Grams. 105.99. I know because it's up there. We used that before, so I'm just reusing the same thing. Na2CO3. And yes, I do like to rewrite these sometime because it's helpful to have it. Just gonna put it that separate so that we don't get ourselves confused. So anyway, so you will see that your mole will go away, right? Leaving you with your grams. Okay, now let's put it together. Okay, so this is about 106, 4.4. It's gonna be a little pain in the butt to do it by hand, so you can definitely use a calculator. But you should always practice doing estimation. So by estimation, that would be 0.16. 0.16 close to 100. That's probably like 10 point something. Okay, I'll lose like one of the decimals. I mean, probably more than 10, but yes. So a little bit around there. Let's see what we get. So 16 right? So I said it's more than 10, like I said, right? But yeah, I mean, I'm not trying to estimate it as close to as possible, but I'm just doing really rough one. Okay, you could definitely do like closer estimation if you're using like scratch paper and you're trying to write out stuff. I'm not trying to write out stuff. So let's see. I'm trying to see how much I should round it to. I think I rounded too much earlier in the beginning. Although doesn't matter. It's about approximating. So I'm just gonna keep it like that. 6, and then we're gonna say that that's the grams of the Na2SO4. Okay. Okay, I'm gonna put the picture aside. Okay, so that's pretty much what we're having, right? So unit cancellation, that's basically in a way still like dimensional analysis, stoichiometry, that kind of thing. You're canceling out unit. Let's look at the next one. An experiment, right, need to use 0.250 mole of sodium carbonate. How many milliliter of this solution will be needed to obtain this amount of sodium bicarbonate? Sodium carbonate. So we do want to wonder how many milliliter do we need. Well, notice they didn't say we're diluting it or anything. They just wondering how much you need to pour it out. So that means what? You are not diluting. The question is not diluting, right? They did not say dilution, right? It's not dilution. So that means what? You're just simply pouring out. So that means still the same concentration. Your number doesn't change. Your molarity still haven't changed yet because I didn't do anything. All I was asking you guys to tell me was how much do you want to pour it out? Make sense? Question? Okay, because I'm asking you that one, I can still use full molarity if you want, because the whole solution is still full molarity, right? So molarity is mole per liter. We can say that. Okay. Now I do have a mole here. Now I don't know if you notice. If you are gonna go ahead and use a stoichiometry to try to cancel the mole like this, what did you notice your answer unit is? What do you notice your answer unit is? It's a liter, but your liter is on the bottom. Do you see that? So it's actually, if you do this, you're gonna get per liter, basically. So if you don't want it, because I'm looking for the liter or milliliter, I gotta flip-flop this thing, basically. So that means instead of writing this, I'm gonna write it this way. I'm gonna say 0.250 mole. I want to cancel out the mole, so I'm gonna flip-flop that. Liter, 4 mole. You gotta know this, that is the same thing, same idea. I just swap the whole thing upside down. Okay, you can do that because look, your units still work, and in this case, we're getting to the one that we want. Okay, now granted that the question is a milliliter, so I should probably do milliliter. Right, so that get rid of my liter also, and we're gonna get your mole. Right, so that's what we're gonna do. Okay. Okay, that's about one. That's 1/4. That's 1/4. So you get 1/16. So 1,000 divided by 1/16. Okay, basically that's what we're having. And then again, I can approximate about a little bit, like like yeah, less than 100, 80, 90, something like that. Again, I'm approximating really bigger number, right? So yeah, we know that, yeah. And my answer, I come out to be 62.5 milliliter. Okay, again, like, yeah, because I don't know how much I need to estimate it. I just do really rough estimate. Like I said earlier, I said it's less than 100, right? And yeah, it is less than 100. It was 62. Now, of course, in a multiple choice, you do have your answer choices to help you guide how close you want to estimate it to. Sometimes really rough estimate is okay. Like in this case, I just do a really rough estimate that said less than 100, right? Okay. Any question about what's going on or what happening? Question. So far, we're good. No problem? Okay, let's go to the next part, H. Again, notice that each question kind of like built on top of a little bit. Now, it's the same question, right? Again, let's pay attention and focus here, please. What volume of above sodium carbonate must be used to prepare, okay, 1.5 liter of 1 molar solution of 1 molar sodium carbonate solution. So this is now dilution problem. Do you guys see that? Because we are trying to create 1 molar solution out of above solution. So above solution is 4 molar solution. So we are now diluting. So they are still asking you volume. They have a new stuff. That's a dilution. This is a dilution question. So if you are dilution question, what is the equation that we're using? Yep, exactly. That's the one that we're using. Okay, I need you guys to make sure that you know that. Okay, again, doesn't really matter, but that's the one that we're doing. Okay, we still know that it's a 4 molar. We just don't know what's the volume that we need to use. We know the new thing is 1 molar and 1.5 liter. Now notice that my volume is liter, so my final answer should be in liter. So I'm going to divide it by 4. So you're going to say 1.5 divided by 4. That's going to be our answer. That should be in a liter. Okay. So less than 0.4. 0.375 liter. Okay. Now, if they don't really say anything what volume, you can just leave it there. If they say find it in the milliliter, then you want to change it to milliliter and you want to say 375 milliliter. Now, if they don't say it, you can leave it in that way. Both of these answers are okay. All right. So watch the question. Okay. A student need. Okay. Well, that's number 2. Number 2 is the same thing as number 1. How do I know? Because I write it so that they are all the same. So except for like different volume, different number, different chemicals. So I think 2, 3, yeah, 2 and 3 are the same thing as what you have here. Any question about 2 and any question about 1? Okay, so if I ask you to repeat it, can you do 2 and 3 on your own? Yeah, we're fine? Okay. Yeah, pretty much the same stuff. Okay, got it? Alright, so step is pretty much the same thing. Now, for the step, notice that this time I'm just creating from the solid thing. Sometimes you could be creating from the liquid. So if it's liquid, it's just gonna be, instead of gram measuring the volume, you just, measuring the mass, you're gonna have a volume. So a little bit different, but same idea. Okay. All right. Let's look at number 4. I think number 4 is pretty much similar, but I just wrote it different stuff. Let's see if you guys know how to do it. Okay. So I just shortcut it. If you know number 4, I think you know how to do the rest part. Okay. Let's work through this. What is this asking? Okay. Molarity or what? All right. See, read the whole thing. Otherwise, you're going to get yourself in trouble. Molarity of chloride ion. That's the one that we're looking for. Okay. To find molarity, what do we need? Find the mole and then find the volume, right? Do we have a mole? No, we don't. But can we find it though? Yes. Okay, let's do that. So we're going to use that to find the mole, right? 13.45 gram of copper to chloride. So that is Cu. What's the formula? Cl2. Good. Jenny, you still with us? Okay. Now let's convert it. Time. Gram CuCl2 on the bottom. Mole CuCl2 on the top. 1 mole. Okay. Now I don't know if you guys notice. It's that molarity of chloride ion and not the whole thing. So if you want, right here, you could just convert it to just chloride ion. So we can say 1 mole of CuCl2 has how many mole of Cl minus 1 ion? 2. Everybody got it? If you want, you can change it right here. If you don't want to, you can also convert it to molarity, and then you can just say, okay, there is 2 of them, so multiply by 2 later. Either way is fine. I just like to do ahead so that I don't get myself confused. And now I got to pick up CuCl2, 63.55 plus 35.45 times 2. So we're going to get 134.45. Okay, cool. All right. If you want, you can also continue from that step and then just solve it. Or you can do on a separate step. I'm going to do in a one step and solve it is this way. You can see that gram go away. My mole of that go away. I already have a mole of Cl minus. To find the molarity, right? To find the molarity of Cl minus, right? To find the molarity of Cl minus concentration, what do we need? Mole and then volume, liter, right? So I can just say divided by liter on the bottom like that, right? I don't have to write in a second equation. Does it make sense? I like to always set it in one equation if possible. If you guys want to do 2-step, that's fine too. Okay, so 200 milliliter, so that means 0.2 liter. Okay, so when I solve, okay, hopefully you can do this without calculator. Take a look. What's that gonna give us? 0.1, because the bottom is bigger. Because it's 110, so 0.1, right? 0.1 times 2 is 0.2. 0.2 divided by 0.2. 1. We're back to 1. 1 molarity of the Cl minus. Or you can write Cl minus concentration is equal to 1 molarity. Okay, either way. Alright. What volume above solution must be used to prepare 500 milliliter of 1.2 times 10 to the negative 3 molarity of HCl solution? Uh-oh. Wait a minute. Okay, I actually wrote it wrong. It's not supposed to say HCl. Go ahead and change it to CuCl2 solution. Because, yeah, I think I was Einsteining some question, like Frankensteining, adding them up, and then getting in trouble. So that's still CuCl2. All right, so that's a dilution question. So for the dilution question, what do we want to do? Yeah, same thing. M1V1, M2V2, right? So M1V1 equal to M2V2. Okay, M1. Now notice though for the M1, can we use this one molarity? No, because what is that 1 molarity concentration of? Cl. Okay, what is that molarity concentration of here? CuCl2. Yeah, you can change it. So I don't necessarily want to do that. I can go back there. I can change it. Pretty much you can drop this part here, right? Then you can figure out what is the CuCl2 concentration gonna be. Okay. Yeah. So CuCl2 concentration will be 0.5 originally, right? So above question, your CuCl2 concentration is actually 0.5 molarity, right? Cl minus just happened to be 1 because there's 2 of them. Okay, so I'm gonna need to use that one. So again, notice in chemistry, not just looking at moles, gram, molarity, you also have to look at the chemicals. Make sense? Okay, so this is where people always get in trouble. Okay. When you're doing the physics, you have to look at the direction. When you're doing the chemistry, you have to look at the chemical's name. Otherwise, things get very, very confusing. Okay, volume here is 500. Notice that it's in that milliliter. So your final answer here, when you write it, it is in milliliter. So notice that that's what we're having. So we're going to say volume equal to, okay, 1.2 times 10 to the negative 3 times 500 divided by 0.5. Okay. Can you solve this without calculator? Actually, you could. Let's say I'm going to show you. Let's say we don't want that decimal, right? Notice that they are both 5, so this is what I'm going to do. If not, you can just convert 0.5 into half. So divided by 0.5 is the same thing as multiplying by 2. If you want to do that, you can also do that. Okay, so there's two different ways to do it, but either way is the same thing. One other way is, notice that divided by 0.5 is the same thing as multiplying by 2. So that means that 500 become 1,000. See that? That's one other way. Another way I do is this. I know that they are both 5, so I can cross it out. Basically, I don't like dividing my decimal, so I usually move one. So when you move it, that's become extra 0 right there. So you can see that 5,000 divided by 5, that's 1,000. Do you see that? It's the same thing. So pretty much from this point, you get 1.2 times 10 to the negative 3 times 1,000. I don't know if you know what 1,000 is. Instead of saying 1,000, I can just say that's 10 to the 3. Do you see that? 1,000 is 10 to the 3 because 1, 2, 3. If you move it, 10 to the 3 times 10 to the negative 3, that is 1. I don't know if you guys learn how to do exponent. Same base. The exponents, when you multiply, you add them up. Negative 3 plus 3, that's a 0. 10 to the 0 is a 1. Okay, so therefore my final answer is 1.2. And then since it's a milliliter, that's still a milliliter. Okay, so I need just a couple drop of the original solution to make 1.2 times 10 to the negative 3 molarity of the solution. 500 milliliter of that. Question about this? Yeah? Okay. Let's talk about next one. Okay, so we're back to stoichiometry. Now, notice that some of the stuff here, I do give you the equation in Word so that you can write your balance equation. A little bit later on when we talk about acid base, you will stop like getting like the product pieces because you can't figure out what the product pieces is. Okay, so let's take a look. Calculate the mass of sodium chloride that must be added. Okay, so we're adding sodium chloride. Now notice mass to the 1.5 liter of this molarity nitrate solution. Okay, what do you think that information will do when you see this information? What should that be screening out of the paper as to what to find? Molarity, liter. What do you think that should tell you? Mole. Do you see that? So sometimes a little bit things like this will help. You notice that will, you can find more of that. Okay. Now we're gonna continue reading. To precipitate all the silver ion in a form of silver chloride. So this is gonna be your solid, your precipitate. Okay. So I should be able to write out what is happening here. So we're gonna say NaCl, right? You're gonna react with the silver nitrate, AgNO3. We know one of them, AgCl. That's gonna be precipitate. That's our solid. You don't necessarily have to write it. I'm just writing it so that we know. And then what? This ink is really bad. Leftover, NaNO3. Okay. Just a quick quiz or quick checking. Which one is a spectator ion in this equation? Yeah, because we're gonna dissolve Na, so Na doesn't really do anything. My NO3 is not gonna change. It's gonna be iron because this is the aqueous solution. This is gonna be dissolved, right? Okay, cool. Calculate the mole of the reactant, right? They said convert molarity to mole, which is what I was telling you up there. So let's do that. So we're gonna say 0.100. Molarity just means mole over liter times 1.50 liter. That will give us mole. And also I want you to keep writing what is the chemicals you're dealing with so that you can kind of keep track of it. This is silver nitrate, AgNO3. Question about this? Okay, again, you don't need a calculator to multiply these two. 0.1 times 1.50. 0.150, right? Okay, you just move one decimal. Everybody get it? Okay, if you're not sure how to multiply these, you should definitely remember or know some of that tip and trick that I show you. Okay, now we need to calculate the mole of desired compound. Desired compound that we're looking for is the sodium chloride. So we're gonna convert that to the sodium chloride. So we're gonna say 0.150 mole of AgNO3, well, in this case, you know that they are 1-to-1 ratios. 1 mole of AgNO3 is gonna give you 1 mole of NaCl. Obviously, if you're doing multiple choice, you don't have to show all these steps, but because I'm showing you free response and I'm also showing you how to write them, you should definitely have some sort of things in them. Don't just say the answer, okay? I know it's 1-to-1 ratios. You know it's 1-to-1 ratios. Or if you don't want to say this, you can just say 1-to-1 ratio based on the balanced chemical reaction equation. Okay, something like that. Something need to be there. Make sense? Okay, if this was like standalone not multiple choice, free response question, if you just tell me this without any other work, you're not gonna get credit. Okay, I need to see some kind of thing. Either you write this thing 1-to-1 ratios, or you can write in a word form. You can say like, you know, the NaCl and AgNO3, you need the same amount based on balanced chemical reaction, whatever it is, that's fine. Okay, now you get moles. We're not done yet. Since the question is asking for mass, just convert it. So you're gonna say 0.150 mole NaCl. I don't want that one. So 1 mole NaCl, gram NaCl. Also notice the molar mass conversion. This guy doesn't work on everybody. Let's say here, if the mole wasn't saying NaCl, let's say the mole here says some other chemicals, and you are using this, it will not work. Make sense? So for example, this mole says NaCl, and I'm gonna use it to convert it to, I don't know, like NO3 or something. It will not work. Okay, but in this case, it's sort of this because they are 1-to-1 ratios. But generally speaking, you cannot just randomly convert it. Okay, because I see people do that all the time. They will use a sample which has CHO, and then you convert it to carbon dioxide. And I'm like, how did you know? Like, it's not 1-to-1 ratios. Okay. All right, so let's go through that. Again, if you do have a question, please stop me and please ask me a question. Today is we can actually take our time going through that. And I know I'm naturally very fast at saying things. So, all right. So let's convert that. I don't know. It's greater than 0.5, probably even more than 0.6. I mean, not 0.5, sorry, 5 point something or 6 point something, maybe even higher. Okay, well, 8 point something. There you go. Yeah, because like I said, it's some kind of higher than that, right? 6 gram NaCl. Again, you can definitely guess these numbers. For example, if you were to ask me to guess, like I was saying, this is 58. This is about 0.1, or you can say 0.2 is between 0.1 and 0.2. So, you know, you can guess like where the number is gonna be. All right. Any question about that one? Okay. Let's look at number 2 question. And then number 2 is pretty much the same thing. Again, I just kind of break it up so that you guys can calculate them. I showing you step by step, sort of. Okay, so it's that how many milligram, I mean not milligram, sorry, I'm not reading it correctly, milliliter. So that's it, ml. Of 5 molar, really, copper 2 nitrate. Okay, you should know copper 2 nitrate, CuNO3 2, right? Are required to completely precipitate all the chlorine ion in this grams of potassium chloride. Okay, so we're trying to do reaction where we're trying to precipitate out chloride ion. So let's try writing it. So this one is a little bit harder to tell, but still similar idea or similar reaction, sort of speaking. So you have copper 2 nitrate, and I'm going to add it to potassium chloride. You will notice this is when we can precipitate your chloride, because when chloride go with copper, that will drop out. Now, if you're not sure, copper here is +2, so we're gonna still keep it the same thing. So therefore, copper here is still +2, so that would be CuCl2. That's my precipitate, that's my solid. Okay, and then my leftover KNO3. When you finish, do not forget this. You're always balancing your equation. Okay? So, there you go. Now we're going to calculate same stuff that we did before, except now we're looking for the volume because we don't have a mole here. So your goal somehow related to is this. You want to find the mole of this guy so that I can use a molarity to find the milliliter. See how it goes? Connection, right? So that means I'm going to start with this guy, gram. Convert that gram to moles. From that grams to moles, and then moles to moles, and then from the moles I can find the milliliter. See that? This is what I'm telling you in a step-by-step here. So balance grams to moles, find the desired moles, use that moles to find liter. Okay, so that's what we're gonna do. So let's do that. So grams is 15.0 gram. Oh no, 550, 150. Okay, forget it. KCl. Alrighty. Okay. So make sure pick up the correct number. Okay. KCl. Okay, that would be a 39.10 plus 35.45 gram KCl. 1 mole of KCl. That will give you mole of KCl. Okay, so let's see. Okay. About 2, I'm thinking. Okay, 150. Yeah, 2. 2.012. Okay, about 2. All right. Now, when you finish, you're going to convert moles to the mole that you want. Now, notice that in this case, this is a crucial one. It's not 1-to-1. You got to be careful about that one. Okay? See what I'm saying? Not 1-to-1. So that means we're going to use 2.012 mole of KCl. 2 mole of KCl is 1 mole of CuNO3, 2. That is going to give you mole of CuNO3, 2. Okay. I'm just going to do that without calculator. That's 1.006. I can divide that one, right? No problem. Okay. Now that I have the moles of copper 2 nitrate, I can now find the volume because I have a molarity of it before. Okay. How do you find the volume from the molarity? Mole times mole. The 1.006 times 5. No, that wouldn't work. Because so if you just multiply that one with this one, then you're gonna get mole square over liter. Right. So the way that I'm saying is because you want to rewrite this into mole per liter, then you will see that unit doesn't match. Flip that one. Yeah, you gotta flip that one. So basically dividing, divided by 5. Right. So if you're not sure multiplying or dividing, check the unit. Okay. Here's what I mean by check the unit. Take a look. I'm gonna write it 1.006. At this point, if you already double, make sure that your mole is the same unit. You don't necessarily have to keep writing the CuNO3 too, because you have make sure. If you're not sure, you can rewrite it. Okay, but if you don't think that you don't need it anymore, you can drop that because you actually double check, make sure. But take a look at this. So what I was saying earlier, we're talking about it, right? Earlier, you might think that you're multiplying, but actually it's not. Because if you multiply, 2 more is going to be on the top. So what you're going to do is you're going to divide it because you're going to say 5.0 is here. And 5.0 is molarity, which is mole per liter, which is mole is going to stay with that 5. And then liter going to jump up there. And then that's just 1 liter because you're just flipping it. And then that's a CuNO3, 2. See how it goes? The unit? See what I'm saying? This is what I'm telling you guys about why I need you guys to write your unit. Okay? Yes. Okay, even in multiple choice, maybe not the whole thing, but like some shorthand or like some quick mark so that you know which unit you're looking at. Okay, because otherwise, can you imagine like you're really, really close to answer and you, instead of dividing, you multiply it? You're gonna lose that point that you work up for to get to there. Make sense? Because you spent time doing all this. Why make a mistake on the last step, right? Okay, so yeah, that's like me going home. I accidentally forgot, like, the last step, left, right kind of thing out of the freeway, turn it the wrong way, accidentally go back on another freeway. I'm like, damn it. Right. Yeah. One time I accidentally crossed the bridge the other side. I'm like, damn. Yeah, I do that sometime when I'm not thinking, which is bad. Don't do that. Okay, so let's see, 5, so that will be about 0.2. Okay. Yeah. So we're back to that number 0.2012 liter. Okay. Now in this case, it just happened to be the same number just because this is 5 molarity. Not always gonna be the case. Okay. Just saying, sometimes your number end up being like the same thing as what you did before. Not always the case. Okay. Now, for this case, are we done when we finish to here? Because if you look at the question, what did the question say? Right. So don't miss that last step. Again, like I said, you're almost home, right? And then you're not paying attention, so you go the wrong way, right? Careful. Like I said. Right. So you're gonna do is you're gonna multiply by 1,000. I'm not gonna multiply. I'm just gonna write the answers. 201.2 milliliter. Okay, and if you guys are trying to keep with a suffix, that's a 2 suffix the whole way. If you're looking at it, okay, there's a 2 suffix there. So I want to keep it 2 suffix, but except it's 0 is a little hard to do. Then you can do it this way. You can say 2.0 times 10 to the 2 milliliter. Okay, that works also. Question? All right, I'm gonna stop here, and I want to let you guys digest your stuff. And I think